डॉक्टर अनूप कुमार शर्मा, SPNKS गवर्नमेंट PG कॉलेज दौसा से M.Sc फाइनल केमिस्ट्री के पेपर नंबर 504 की यूनिट 4 रिएक्शंस एंड रीअरेंजमेंट्स के अंतर्गत इस व्याख्यान में आपका स्वागत करता हूँ। Today we will discuss the Curtius reaction. What is Curtius reaction and what is Curtius rearrangement? So there is always a confusion in students whether what is Curtius reaction or what is Curtius rearrangement. So today we will discuss both of these, Curtius reactions and Curtius rearrangement. Curtius rearrangement actually a part of Curtius reaction. A fraction of this Curtius reaction is called Curtius rearrangement, which you will understand later after this introduction. Curtius rearrangement involves the decomposition of acyl azide in inert solvent, benzene or chloroform etc. by gentle heat to isocyanate. So the conversion of this acyl azide to this isocyanate is actually Curtius rearrangement. In the conditions are by gentle heating or in presence of some inert solvent. Inert solvent is very important. So the Curtius rearrangement involves the decomposition of acyl azide in an inert solvent, for example benzene, chloroform etc. by gentle heat to isocyanate. So this azide is heated to give isocyanate, and nitrogen in these reaction, whenever you heat azide, always this nitrogen molecule will evolve from this reaction. So now if we have said here that this reaction occurs in some inert solvent like benzene or chloroform. If we take some other solvent, if other solvents are used in place of inert solvents, isocyanate reacts with the solvent. If we take other solvent, then isocyanate, this product will itself react with the solvents. For example, if the reaction is carried out in alcoholic or aqueous medium, the isocyanate further react to form urethane, amine or substituted urea. These are the products which are obtained by the reaction of the isocyanate to the solvent, for example water or alcohol. Here I have written this azide when heated to give this isocyanate. This is Curtius rearrangement, and because this reaction is has been occurred in this reactive solvent, for example in alcohol, then we obtained this urethane, RNHCOO, R-dash, urethane is obtained. When reaction was occurred in alcohol, if reaction is occurred in water, then we will got this primary amine RNH2 plus CO2. This is obtained. And if this reaction is carried out in amine, then substituted urea RNHCONHR, this will obtain. So this is the difference. If this reaction is carried out in some inert solvent, then this the product will be this isocyanate. And if some reactive solvent has been used in this reaction, then some other product, some like urethane and this urethane or substituted urea or amine are obtained in this. So the conversion of the acyl azide to isocyanate involves Curtius rearrangement, while the Curtius reaction involves the conversion of acid to amine, urethane and substituted urea via Curtius rearrangement. So this is the difference. The conversion of acid, this is acid azide and this will obtain from some acid itself. So the whole reaction, the conversion of acid to acidizide and this acidizide to isocyanate and isocyanate further reacts to give this urethane, urea, substituted urea or amine. This whole reaction is called Curtius reaction, while this fraction, the fraction of this reaction in which this azide is converted into this isocyanate is called Curtius rearrangement. This has been written here. The conversion of acyl azide to isocyanate involved Curtius rearrangement, while the Curtius reaction involves the conversion of acids to amine. Conversion of acid to amine. Acid will give azide and azide will give this isocyanate, and isocyanate further react with the water to give this amine. So this whole reaction is called Curtius reaction. So conversion of acid to these products means either amine or urethane or substitute urea is Curtius reaction, while the portion of this reaction in which this acid azide is converted into isocyanate, it is called Curtius rearrangement. So this is the difference. Now I think there should not be any confusion कि एसिड एजाइड से आइसोसाइनेट का बनना कर्टियस रीअरेंजमेंट है, जबकि पूरा रिएक्शन एसिड से और अमीन या अमोनिया व्युत्पन्न या यूरिथेन का बनना मीन्स अम्ल से अम्ल एजाइड और अम्ल एजाइड से आइसोसाइनेट, आइसोसाइनेट फिर इन वाटर से और इनसे रिएक्शन करके जो ये प्रोडक्ट बना रहा है अमीन, ये सारा रिएक्शन मतलब अम्ल से अमीन तक जो बनना है, ये पूरा रिएक्शन तो कहलाता है कर्टियस अभिक्रिया, जबकि उसका ये जो हिस्सा है एसिड एजाइड से आइसोसाइनेट का बनना, ये कहलाता है कर्टियस रीअरेंजमेंट. ये इन दोनों में अंतर है. सो दिस इज द डिफरेंस बिटवीन कर्टियस रिएक्शन एंड कर्टियस रीअरेंजमेंट. नाउ एसाइल एडाइड इज प्रिपेयर्ड एज बिलो. As I have said here कि the whole reaction, that the conversion of acid to this is called to this amine is called Curtius reaction. So how this acid azide is obtained? When acid chloride which is obtained from acid itself, acid treated with sodium azide, so acyl azide is obtained here. Or if we treat this ester with hydrazine NH2, then acyl hydrazide is obtained. When it is treated with HNO2, then with acid azide is obtained. So these are the method by which this acid derivative or acid is converted to this acid azide, or now this acid azide further react to give amine etc. through Curtius rearrangement. Now the reaction is a general one and can be applied to aliphatic, aromatic, heterocyclic and unsaturated acids. So whatever type of acid may be, this rearrangement or this reaction is applied to all, whether the reaction is whether the acid is aliphatic, aromatic, heterocyclic or unsaturated. These acids may contain different functional group which remain unaffected, and further if some functional group is present on the acid, then these functional group remain unaffected during this reaction. So that's why this reaction is a general one and widely used for the preparation of different amines, which we see later in this lecture. So now we come on the mechanism part of this reaction. Mechanism. The mechanism is very similar to Hofmann rearrangement to isocyanate. As isocyanate is obtained, so the similar as isocyanate was obtained in that Hofmann rearrangement, similarly the mechanism is very much similar to that Hofmann rearrangement. This mechanism is very similar to Hofmann rearrangement to isocyanate. The driving force of the rearrangement is the electron deficient nitrogen formed on the elimination of nitrogen molecule on heating. So this is acid azide, acyl azide, and when this rearrangement and this on heating, it give up this nitrogen molecule to give this molecule in which nitrine, in which negative charge or electron deficient nitrogen is there, and this migration of this alkyl group takes place on this nitrogen atom like Hofmann rearrangement, and isocyanate is obtained. So this step is very much similar to that of Hofmann rearrangement. So this acid azide, so the driving force for the rearrangement is the electron deficient nitrogen form on the elimination of the nitrogen molecule on heating. So on heating, this nitrogen molecule will evolve, and this electron deficient nitrogen, this forces the alkyl group to migrate, so isocyanate is obtained in this. So this is the mechanism of this reaction. Since there is no evidence for the formation of the nitrene, all the steps may be concerted. So reaction of isocyanate, so reaction with alcohol, this isocyanate react with alcohol to give urethane. So in all these reactions, you will say the isocyanate react in the way in which the addition on this C carbon nitrogen bond, double bond takes place. So there's in this molecule H added, hydrogen is added to this nitrogen atom, and OR to this carbon atom. So we obtained RNHCO OR dash. Urethane is obtained. So by addition of this alcohol on this CN bond, urethane is obtained. So when this isocyanate further react with is reacted with this water, so carbamic acid is obtained. See, the H plus is added to this nitrogen and OH minus on this carbon atom. So carbamic acid is formed, this RNHCOOH, and by the arrangement of this CO2 molecule is evolved from this, and we obtained primary amine and carbon dioxide go out from this reaction. Now if excess of isocyanate is there, then this isocyanate further react with this amine to give substituted ureas. So when unreacted isocyanate may further react with amine to give derivative of urea. This is isocyanate, and this is react with this primary amine RNH2 to give this alkyl substituted urea. The reaction is same, the addition on this CN bond, है ना? For H is added to this nitrogen, and RNH is what is added to this carbon atom. Now we come on the application part of this reaction. This is a very good method for the preparation of the primary amine, alpha amino acid, aldehyde, urethane, etc. in a simple one step under mild condition. So this is a very good method for the preparation of these primary amines, alpha amino acids, aldehyde, etc. In single one pot synthesis, because this isocyanate is very much reactive and reacts readily to give all these things. Now we see step by step all these preparation. First of all, we see the preparation of primary amine. How primary amines are obtained from through this reaction. Primary amines free from secondary and tertiary amine can be prepared. So this method is very good, because in other method usually we obtained a mixture of primary, secondary and tertiary amine, but in this through this reaction we obtained pure primary amine. So the primary amine free from the secondary and tertiary amine can be prepared by this method. See one example of this reaction. This is ethyl phenyl acetate. This is phenyl acid and this is ethyl phenyl acetate, ester of this acid. Now this is treated with azide and nitrous acid. So this is treated with hydrazine NH2 and nitrous acid. So we obtain azide of this ester or acid. Ethyl phenyl acetate will give this azide of this. This step shows the Curtius rearrangement. When this is heated in benzene, then we obtain isocyanate, and isocyanate further react with water to give this amine. As we have seen earlier, when this isocyanate is treated with water, it gives primary amine. So for the preparation of primary amine, so this azide is is converted to the isocyanate through Curtius rearrangement, and this isocyanate is treated with water to give amine, primary amine. Now other example is the reaction of ethyl anisate. This is ethyl anisate, ester of this acid. Now this is treated with hydrazine and nitrous acid. Similar to that, I have a reaction to give. This is acid azide. This acid azide by Curtius rearrangement, that is on heating with heating in benzene, give isocyanate and with treated with water to give this amine. So we obtain perianicidine. So ethyl anisate give para-anicidine. So this is primary amine. So it's a method. It's a very good method for the preparation of primary amine. Now second application of this reaction is preparation of alpha amino acids. Alpha amino acids are very important, and these are prepared by through this rearrangement. So this is cyanoacetic ester. This is cyanoacetic ester, and this is treated with NaO, sodium ethoxide, and alkyl halide to give this alkyl derivative of this. This will take out hydrogen from this, and when this is treated with alkyl halide, so this alkyl group will be added on this carbon, and now the reaction is similar to above one, in which this is treated with NH2 and nitrous acid to give this azide. This ester group will be converted into azide group. And now we come on the Curtius rearrangement. So this will when this is treated in alcohol, we obtain this ester, and when this is hydrolyzed with acid to give this is converted to this will converted to amino group, and we obtain alpha amino acid. So this is mere an example of this preparation of the alpha amino acid. Other amino acid can be prepared through this reaction. So the second application of this reaction is preparation of alpha amino acid. To primary amine, preparation of primary amine, and preparation of alpha amino acid. Now the third application of Curtius reaction or Curtius rearrangement is preparation of aldehyde. So this is see one example of this reaction. This is lactic acid, CH3CHOH COOH, when treated with this alcohol and acid in presence of acid, and second one with hydrazine NH2 and nitrous acid. So I have written all these things to show you that we have seen this reaction earlier. That's why this acid is converted into, first of all it will convert it into ester, then this ester will be converted into this acid azide. So this will obtain acid azide. Now this is treated with alcohol and heated to give this CH3 CH OH NHCOO. This ester is obtained. So when in presence of NaOH and water, this primary amine is this amine is obtained, in which OH group is, because this is not stable, so it will ammonia will evolve from this and we obtain aldehyde. So this is unstable. This hydroxyamine, this is not stable, it will further give to this CH3 CHO, this, that is aldehyde and ammonia. So acid, we obtain aldehyde, or we have obtained aldehyde from this acid. So this whole reaction actually, as we have seen earlier, जैसा हमने पहले देखा, ये पूरा रिएक्शन जो अम्ल से और सीधे हमें एसिड से सीधे एल्डिहाइड जो यहाँ तक का बनने का ये पूरा रिएक्शन है, ये पूरा रिएक्शन तो कर्टियस रिएक्शन कहलाता है. जबकि इसमें ये जो कन्वर्जन है एसिड का कन्वर्जन एजाइड में, और ये इसका टूट के जो आइसोसाइनेट में कन्वर्जन होता है, वो कन्वर्जन कहलाता है कर्टियस रीअरेंजमेंट. सो दिस होल रिएक्शन इज Curtius reaction. So the third application of this Curtius reaction is the preparation of aldehyde. Now the fourth application of this reaction is for stepping down the acid series. Acid of one less carbon atom can be obtained by this rearrangement or this reaction. So this is acid RCH2COOH. When it is converted to the to ester RCH2COO C2H5, now treated with hydrogen and nitrous acid. So we obtained RCH2 and this azide is obtained. Now this Curtius rearrangement, heated in benzene and then treated with water in second step. So we obtained amine. So we obtained RCH2NH2. Now this amine is treated with nitrous acid to give alcohol, and when this alcohol is oxidized, it will give acid which have one less carbon than the parent acid. So in this step, and this is very interesting, the reaction up to this formation of primary amine, यहाँ तक इस एसिड से लेके और ये प्राइमरी अमीन बनने तक, यहाँ तक का ये पूरा जो रिएक्शन है, ये कर्टियस रिएक्शन है. और इसमें ये वाला जो स्टेप है RCH2CON3 से ये जो कन्वर्जन है प्राइमरी अमीन में, ये जो स्टेप है ये कर्टियस रीअरेंजमेंट है. सो आई थिंक द डिफरेंस बिटवीन कर्टियस रिएक्शन एंड कर्टियस रीअरेंजमेंट इज क्लियर. So this is the fourth application of this Curtius reaction, the stepping down an acid, the series. We obtain an acid which has one carbon less than the parent acid. Now the fifth application is the Curtius reaction is used for the synthesis of antiviral drug oseltamivir, or is the common name of this is Tamiflu. So it is very good reaction to form this Tamiflu, which is used as antiviral drug, especially in avian flu. This drug is very much widely used for the treatment in avian flu. So it is also used in the preparation of diiodamine. This is also it is also used for the preparation of diiodamine, a natural product which is used for in traditional Chinese drugs. So it's एक plant species होती है, उसको ये वहाँ से ऑब्टेन होता है, एंड द इन सिंथेटिकली इट इज prepared through this reaction, and this is used in the Chinese traditional drugs, and it also used in the preparation of triquinine tri and this is also used in the preparation of triquinacine. This is triquinacine, 5 member rings, 3 5 member rings are attached in this way. So these are some application of this Curtius reaction, that is preparation of primary amine, preparation of alpha amino acid, preparation of aldehyde, and stepping down an acid series in an acid series, and for the preparation of Tamiflu, etc., various other drugs. So this was about Curtius reaction and Curtius rearrangement. Thank you.